Hello, my dear students. I welcome you all on my YouTube channel, Dr. Vikas Kamra. In the previous video of data structure, we covered a numerical of two-dimensional array to find out the address of an element stored in a 2D array in row major order as well as column major order. Today in this video, we'll cover a numerical of three-dimensional array to find out the address of an element stored in a 3D array. We'll cover both row major order and column major order. So let us start with the example. This example is taken from Shom's outline series book of data structure. So let us take an array of size 2 into 4 into 3. Here 2 is the number of rows, 4 is the number of column, and 3 are the pages. This is the new element introduced in three-dimensional array. So it means there are 3 pages of size 2 by 4. So total number of elements stored in this three-dimensional array is 24. 2 into 4 into 3. So I'll show you its representation in memory. So you can see this particular diagram. It is the representation of a three-dimensional array in memory. So I'll explain you this diagram. Here you can see this is a single page of size 2 into 4, which means it is a 2D array. It is another page of size 2 into 4. It is second page, so second two-dimensional array. This is third page of size 2 into 4. So there are total 3 pages, page 1, page 2, page 3. So 2 rows, 4 columns and 3 pages. So total number of elements are 2 into 4 into 3. 24. So today we'll cover our example for this particular array of size 2 into 4 into 3. So let us start with the example. You are given a three-dimensional array. The name of the array is maze. Here you are given the dimensions of all three, say x, y, and z. Or you can say rows, columns, and pages. The starting index and ending index is given, but the length of each dimension is not given. So the very first task in this particular three-dimensional array is to find out the length of each dimension. So the formula to find the length of first dimension is upper bound minus lower bound plus 1. So you need to remember this formula, upper bound minus lower bound plus 1. So for the very first dimension, the upper bound is 8. Here 8 minus 2 plus 1. So total size, or you can say length of first dimension is 7. I'll show you once again with the second dimension. So it is for number of columns. So the formula to find out the length of second dimension is upper bound is 1. So 1 is written here. Lower bound is minus 4. So minus 4 is written here plus 1. So 1 minus minus 4 plus 1. So it becomes 6. Similarly, for the third dimension, or you can say number of pages in the 3D array, the upper bound is 10, lower bound is 6, and plus 1, it gives you the value of 5. So we have find out the length of all three dimensions of the given 3D array. So we found the length as L1 is equal to 7, L2 is equal to 6, and L3 is equal to 5. So this is similar as we did in 1D array and 2D array. So now again in 3D array, very first step is to find out the length. Now most important, the second part in 3D array is to find out the effective indices That means value of E1, E2 and E3. Without these effective indices values, you cannot calculate the address of an element stored in a 3D array. So now, how to calculate effective indices? It is very important, so listen carefully. To find out the effective indices means the location for which you want to find out the address. In this example, location is given as maze 5 minus 1 8. So you need to remember that here 5 is the number row, minus 1 is the column, and 8 is the page. So because you can see here 2 to 8 is the number of rows. So out of 2 to 8, I need to find out the effective indices for fifth row. Again, minus 4 to 1 is used for column. So for minus 1, I need to find out the indices for column. Similarly, for the page, the upper and lower bounds are given 6 to 10. So in between 6 to 10, for value 8, I need to find the effective indices for page. This 5 minus 1 and 8, it is given to you. It is the location for which you want to find out the address, and by the help of this location and the lower bound, you can find out the indices value. So now I will tell you how to find out the effective indices. So you can see here the formula to calculate effective indices is location minus lower bound. E is equal to location for which you want to find out the address and minus lower bound. So you need to find out indices 1 for row, indices 2 for column, and effective indices 3 for page. So now you can see here E1 is equal to 5 minus 2 is equal to 3. Here 5 is the location of row and its lower bound is 2. So 5 minus 2, it becomes 3. Similarly, for column part, again effective indices has the same formula. Location is given minus 1 here and its lower bound is minus 4. So minus 1 minus minus 4, which becomes 3. Similarly, for third effective indices, that is for page in three-dimensional array, you need to find out the location, which is given here 8, and the lower bound, which is given here 6. So 8 minus 6, the third effective indices is 2. So now you can see once again, I have find out the value of L1 as 7, value of L2 as 6, value of L3 as 5. Similarly, value of effective indices 1 is equal to 3, value of effective indices 2 is equal to 3, and the value of effective indices 3 is equal to 2. So these 6 values will help us to find out the address in row major order and column major order. So now a shortcut I am giving here to all of you, because it is very difficult in multi-dimensional array to derive the formula. So I have derived the formula for three-dimensional array, and you can remember these formulas here. So the formulas are given here. You have to remember these three formulas if you want to find the address of an element in a three-dimensional array. Same formulas were given for 2D array in my previous video, but in 3 dimension for column major order, this is the formula you can see, and for row major order, this is the formula you can see, like K1, K2, K3. It is the location, number of row, number of column, number of page for which you want to find out the address. Here C is the name of array. Base address will be given to you. Word size be given to you. It is somehow 200 in the previous example. It was 4. Now you just need to fill the value of E3 L2, E2, L1, and E1 here. Similarly, if you are talking about row major order, again K1, K2, K3. These three are the number of row, column, and page for which you want to find out the address. Again, same, you need base address, it will be given to you. You need word size, it will be given to you. You need to put the value of E1, L2, E2, L3, and E3. By putting all these values, you will get the required address. So I'll show you these formulas once again. Just remember these formulas. Now, coming back to our given question, here you have seen that values of L1 is equal to 7, value of L2, value of L3. Similarly, E1, E2, E3. So you need, and in this question, it is given that you need to find the row major order representation address. It will also be given to you. It may be column major order given to you or row major order given to you. So once you will have all these values L1, L2, L3, E1, E2, E3 and given row major or column major, you need not to remember these steps given in the book because I have derived a shortcut formula. So you just put all these values in the given formula. I'll show you the example once again. So the values are 765332. So now coming back to the row major order calculation. So this is the row major order calculation. So here you can see we have to put the base address which is equal to 200. Word size is 4. Now we need to check the E3, L2, E2, L1 and E1 value. So E1, E2, E3 and L1, L2. We'll go back to the previous slide and see E1, E2, E3 and L1, L2 value. So E1, E2, E3 are 332. So 332 and 76. These are the values which we need to fill. Plus 3, this is one bracket. 7 plus, it is multiplied by 7. Then after that 3 is added. So we'll find out the value 12 plus 3, 15. So 15 into 7, then plus 3. What is the answer of this? 105 plus 3. So it became 108. So the whole value here became, this complete value became 108. It is given 4 plus base address is given 200. So 108 into 4, 432 plus 200. So answer became 632. It is the answer for column major order. Similarly, you can calculate the answer for row major order. So I'll show you the once again the question given in the book. So here for row major order, answer came 628. And for column major order, we find out the answer 632. So this is for column major, this is for row major. So students, this example is very important. I will sum up with a few points. You need to calculate L1, L2 and L3 value. Again, you need to calculate E1, E2 and E3 values. E1, E2, E3 are the effective indices. L1, L2, L3 are the lengths of array. These are the upper and lower bounds of row, column and page given to you. The name of array is maze. It is a three-dimensional array and you need to find out the address of this element 5, -1 and 8. So in this way, you can find the solution. For row major order, you have to put this formula. So these are the formulas shown here. For row major order, the formulas is given here as well as for column major order. I have derived these formulas. These are not given in the book. So you can remember these formulas for 3D array and you can directly put the values here and you can get the answer. So This is all about three-dimensional array. So I hope it is clear to you. So you can subscribe to my YouTube channel for multiple videos on data structure important topics as well as career guidance and podcast with IT sector employees, which are my alumni students. So I hope you enjoyed this video. Please share this video with your friends. Thank you very much.